Hello scientific brilliant people, how are you today? I hope everybody fine. Today we will discuss the second chapter.
Density. We have to understand what density is. In the same given amount of space, if there are more things, we say that it's denser. Density is to be the measure of how compact the mass in a substance or object is. It is mass per unit volume, and based on this formula, we can say that its unit is kilogram per meter cube. So can you tell me that what is relative density is? Look at the word relative. It tells us that we are looking at the density of something related to the density of something. We are comparing the density of one thing to the density of another. That's all. But the question is related to what? Answer is related to water. Yes, we look at the density of an object related to the density of water. How to be defined as the relative density of substance? It's equal to the ratio of its density to that of water. Yes, density of the substance divided by density of water. Can you tell me the unit of relative density? Look at the right hand side and tell me the unit. As it is the ratio of the similar quantities, relative density will have no unit. Units of numerator and denominator will be cancel each other out. So there is no unit. Density of water equal to 1000 kilogram per meter cube. Density of silver equal to 10,500 kilogram per meter cube. Can you tell me the relative density of silver? Just use formula and try answering it. Density of silver divided by density of water. Substituting the values, you will get a 10.5. 10,500 divided by 1000 kilogram per meter cube. Kilogram per meter cube will be cut off. You will get the answer 10.5. That is the relative density of silver. What can we understand from this? The silver has lot more than denser than water under the given condition. Approximately 10.5 times denser. This tells us another important thing. It tells whether the object will float or sink in water. In simple terms, a substance will sink if it denser than the liquid it placed, and it will float if it's less dense than the liquid it placed. How can we say it mathematically? If relative density is greater than 1, it will sink. If relative density is lesser than 1, it will float. Relative density of silver 10.5, which is greater than 1, so it will sink in water. But if we take ice, its density is approximately 934 kg per meter cube. Relative density is 0.934. 0.934, that is less than 1. It will float in water. We can understand this with a simple diagram. Take 4 beakers filled with water. In the first one, drop a substance with a relative density 0.1. You see this float like this. In the second one with a relative density 0.4, and you can see that it's float like this. More of it inside. And if 0.9, even more of it will be inside the water. But it will still float. And if it is greater than 1, example 1.2, 1.3, it will be sink. Okay. One last question for you. Can be the relative density of an object be 0? The answer is no. It can't be 0. Because relative density is 0, it means density is 0. Which in turn will means the mass of the substance is 0. For any given substance, mass in a given volume cannot be 0.
Method to find the volume of irregular shaped objects like a stone over here. So for that, there are two methods. The first method is water displacement method, in which you record a measured cylinder or a beaker, but they should have proper graduation on it. And the another method is Eureka can method. See here, I already filled water in this beaker till 150 ml, and this Eureka can is made up of copper. It is very light can And as you can see a nozzle over here, so I cannot fill water more than this level because excess water will be flow out from here, and this is almost, I already filled it completely. So if I try to pour more water, the excess water will flow out from here. There is no water inside this one. And now what I'm going to do is I am going to immerse this stone over here. So we know, as if I will immerse here, the water level will increase. I know what is the initial volume. After immersing the stone, I will record the final volume. The difference in both the volume or the amount of water level increased, volume of water increased, will be the volume of the stone. The same thing I would be repeating over here. I would be immersing the stone inside this and the water will be flow out. Here also the volume of the water will recorded, and the increase in the volume of water or the water which displaces out, that will be the volume of the stone. Both of the methods are same, but this has got an additional advantage. We can calculate the upthrust or buoyant force exerted by the water on the stone, not over here. I am going to immerse this stone over here. See, water level also raised. Initial volume V1, that is 150 ml. Now after immersing stone, final volume V2 172 ml. And the difference in volume 172 minus 150 ml, that is 22 ml. That is the volume of the stone. Now I will dip the stone in Eureka can also. That time excess water will be poured out and it will collect it in small beaker. You can see that the liquid collected in the small beaker. Let the water collected over here. Here also I can see volume of water displaced get collected in the small beaker. That is equal to approximately 22 ml. That is the volume of the stone.
It is a small bottle having a plug at this neck. This bottle can store a definite volume of a liquid. Normally, volume of the bottle is 20 ml to 100 ml. The plug has a narrow opening through it. Excess liquid flows through the hole. The bottle will have the same volume of liquid whenever it is used. Okay, children, volume you can find out mass by density. Otherwise, water you are using, then you can say volume equal to mass. Density of water is 1 gram per centimeter cube. So the volume of water needed to fill the bottle completely is given by its mass. Clear?
When you drop a bottle in the fluid, you will see that it will float. That's because the fluid is applying upward force on the bottle. Now hold the bottle and push it inside the liquid. You notice that the bottle is also exerts an upward force on your hand. If you leave the bottle, you see that the bottle will come up on the surface on its own. Now push the bottle deeper inside the fluid. You will feel more force against in your hand. And when you leave the bottle, it will rush back to the surface. It will come up faster than the previous case. The upward force increases when as it pushes deeper into the fluid. That because the pressure also increases as you go deeper into the fluid. This upward force exerted by the water on the bottle is known as upthrust or buoyant force. Principle of flotation. When a cone is released in water, it immediately rises up and floats on the surface of water. But a stone is released in water, it sinks to the bottom. Since a body is released in water, the following three conditions. Case 1. The weight of the body denoted by W greater than upthrust, that is U. In this case or in this condition, the body will sink. For example, when a stone is released in water, it sinks. The density of a sinking body is greater than that of the liquid. In case 2, if the weight of the body is equal to upthrust, then in this condition the body starts floating just inside the surface of the liquid, as shown in the figure. Thus, the apparent weight of the body is W minus U equal to 0 for a floating body. Also, the density of the floating body is equal to the density of the liquid. Finally, in case 3, if the weight of the body is less than the upthrust, in this condition, the body floats on the surface of the liquid just like a coal in the figure. Actually, a body floats partially on the surface of liquid if the part of the body immense on the liquid surface displaces liquid equal to the weight of the body. The density of the body which partially sinks in the liquid is less than that of the liquid. I hope everybody understood the concept.
Application of flotation. Ice float in water except water. Other solid forms are denser than its liquid form. But in water case, ice is less dense than the water. That ice water property only that one. So it is float in water. Swimmers can easier to swim in seawater than in river water because seawater contains salt. Inside the water, salt molecules are also there. So obviously it will denser. Okay, then denser than this body. So the body can float easily. Then sailing of ship in water, that also we discussed. Floating submarine, same reason only. Iceberg now, just now I told. And see, rising whales, but whales, air bladder filled with air, then air is less denser than water, so it can be come up. When it will emptied, that air will be emptied, then it filled with water bladder, that time that will be whales will sink. Like that only balloons also. See, this one important, that means the iceberg floating, and 1/3 only we can see in sea, and 3/4 it will be merged in water. Why? Because the density of iceberg nearest to 1. See, so 0.9 gram centimeter raised to -3. Density of seawater is 1.02. So see, approximately coming. So 1/3 is upward and 3/4 down the water. So visibility is too less. So every time sailors upbraiding about the iceberg in sea. Okay children, I hope you understood this chapter.
For you, one question: why it is easier for a man to swim in seawater than in fresh water? For you, take a seawater and fresh water, river water. In seawater, you know, salt is dissolved in it. Small salt particles are there along with the water molecules. There, river water, only water molecules are there. So you know that with salt particle, water molecules, then it is denser than the river water. Am I right? Then seawater is denser. Density of seawater is greater than the river water. Then density of seawater is 1.03 gram per milliliter, and density of normal water, that is 1 gram per milliliter. Buoyant force formula is FTG, that means density is directly proportional to buoyant force. That means upward force is greater than in seawater. So the swimmer feel easy to swim in seawater. Upthrust is more. Okay.
Heat capacity is one of 3 factors which helps us understand amount of heat gained or lost by an object. Heat capacity is defined as amount of heat an object can hold. For example, if you keep a steel plate and a wooden object in the sunlight, you will notice that steel plate's temperature will rise very fast, whereas wooden plate's temperature will rise slowly. This happens because heat capacity of wooden plate is more compared to steel plate. Since steel has less capacity to hold the heat, it gets hot and starts losing the heat in the form of radiation. In mathematical terms, heat capacity is defined as amount of energy required to increase the temperature of a matter by 1 degree centigrade. Heat capacity equals amount of energy required divided by change in temperature. If you notice, there is no mention of mass in above formula. For a 10 kilograms mass, we will require more energy to raise the temperature by 1 degree compared to the mass of 1 kilogram. So we can say that heat capacity depends on amount or mass of matter. To make heat capacity amount or mass independent, we use specific heat capacity. Specific heat capacity is defined as amount of energy required to raise the temperature of 1 kilogram mass by 1 degree centigrade. 1 kilogram of wood has different heat capacity than 10 kilograms of wood, but both have same specific heat capacity. Specific heat capacity varies only from matter to matter.
I hope everybody understood the chapter very well.